Welcome back. Today we're quantifying the relationships we saw Monday using the correlation coefficient, known as Pearson's R. Pearson's R measures the strength and direction of a linear relationship between two quantitative variables. Values range from -1 to +1. A value near +1 means a strong positive linear relationship. Near -1 is strong negative. Near 0 means no linear correlation. Here's a quick guide. 0 to plus or minus 0.3 is weak, plus or minus 0.3 to plus or minus 0.7 is moderate, and plus or minus 0.7 to plus or minus 1.0 is strong. Remember that R only describes linear relationships. Always check a scatterplot too. In Excel, you can calculate correlation with equals CORREL, array 1, array 2. Just plug in your data ranges. You can also use the data analysis tool pack a correlation to generate a matrix for multiple variables. In R, use cor.test to get R. To include a hypothesis test, use cor.test x, y, which gives a confidence interval and p-value. This tells you if the correlation is statistically significant. You have 6 scatterplots and 6 correlation values. In small groups, match the R values to the graphs. Think about strength and direction. Respond in the class discussion. Stop the video for each of the next 6 slides. Record and explain your thoughts. Let's walk through the matches together. Scatterplot 1 had points tightly clustered along an upward trend. That's a strong positive correlation. About R is almost equal to plus 0.97. Scatterplot 2 had a tight downward trend, a strong negative correlation. R is almost equal to minus 0.97. Scatterplot 3 showed a cloud of points with no real trend. That's no correlation. R is almost equal to 0.03. Scatterplot 4 had a slight upward trend but with a lot of scatter, a weak positive. R is almost equal to plus 0.42. Scatterplot 5 was a fairly visible downward trend but not as strong. That's moderate negative. R is almost equal to minus 0.66. Scatterplot 6 was a broad upward trend, a moderate positive. R is almost equal to plus 0.72. This activity highlights how interpreting correlation requires both the number and the visual context.